Okay, so now let us complete the last part of this unit number 4. So we are discussing about the materials for 3D printing, and we have already covered the material like plastics, metals, resins, ceramic, composite in the previous videos. Now we will discuss now the advanced the features for the 3D printing. So now we will discuss the 4D printing. Now, what is this 4D printing now? So 4D printing, it is an advanced form of 3D printing where the printed object can change its shape or properties over time in response to external stimuli. Okay, so that means the printed object can change its shape or properties. Now, if you see in this video, the printed part, it is now changing its properties. Okay, so now see, now it is uh, contracted. Okay, so uh, now when the printed part changes its shape when it comes in contact with the stimuli, external stimuli, which may be temperature, light, water, or other environmental factors. Now, in case of this 4D printing, we know the 3D printing, three dimensions. The fourth dimension here is a time. Okay, so 3D printing. So develop a part using the 3D printing. Then you have to add here the stimuli. Okay, and when it comes in contact with the stimuli like temperature, magnetic field, electric field, or any other, so then the printed part changes its shape. So that process we called as a 4D printing. Okay. Now, for this prototype printing, what we require the smart materials. So, smart materials, these are also called as stimuli responsive material, and these are very essential for 4D printing. These materials can alter their shape, properties, or behavior in response to the specific environment triggers. Now, which are these materials? These are shape memory polymers. They change when exposed to the temperature. When you are using shape memory changes, so we have to use stimuli as a temperature. If you are going for a hydrogels, so we have to go for the water or humidity. Liquid crystal elastomers, so we have to the stimuli use are the heat or light. So here you can see the videos here. The 3D printed part, they are changing their shape when they are coming when they are coming in contact when they are coming in contact with the stimuli. Okay, so this is in temperature like this. Now, designing the 3D printing object requires sophisticated software to model how the object will respond to stimuli over time. Computational design tools simulate the transformation process, ensuring the final product performs as expected. So, in the software, we have to design the final output also. Okay, so for that purpose, we have to use the sophisticated software. Now, what is this 3D printing process? We have to first select the material. So smart materials we have to use which provide the response to specific stimuli. That material we have to choose for the 4D printing process. Initially, we have to cover the 3D printing techniques such as we can prepare the 3D printed part using fused deposition molding or SLA or SLS printing. The design must incorporate a smart material. So while printing the parts, we can use the 3D printing techniques, but with the smart material. Post process after printing, the object may require additional processing such as heating, chemical treatment, or manipulation. Activation: when expose the printed part to the external stimuli to get the desired transformation. For example, hitting an object printed with shape memory polymers will cause it to change the shape. So here, this is the videos that is given. Now here, 4D printing simulation software. Which software we can use? Autodesk, CATIA, open source simulation software for self assembly and design constant optimization. So we can use this software. 3D printer with capability to print smart materials. Smart materials are Stratasys, ROVA, SolidView, Geomagic. Okay, so this type of printers we can use. Material that change the shape upon external stimuli. So shape memory allows and shape healing the materials. So this is the Autodesk Cyborg 4D printing software. So we can simulate the 3D print, the final product here in the software. Okay. Uh, Now, 4D printing applications, so self-assembly stains. So in medical applications that we can use responsive clothing. when it comes in contact with the stimuli, so it changes its shape, color, something like this. Safe healing fabrics, adaptive building materials. Okay, so these are the certain applications of the body printing. Adaptive wing structure. So in case of the aerospace, self-preparing surfaces, adaptive interiors, aerodynamics components. Okay, so that we can do. Now, after that, we have the bioactive materials. Actually, bioactive materials for the printing represent an exciting interaction of biomedicine and advanced manufacturing technologies. These materials are designed to interact with biological systems and can be used in various medical applications, including tissue engineering, drug delivery, and regenerative medicine. So here we have biomaterial inks. We take that into the 3D printer, and we'll develop the different types of these the medical parts. So that is called as the bioactive materials. Okay. Now types of bioactive materials. So polylactic acid, caprolactone, alligate. These are the materials are there. Hydrogels. We have to use this type of the hydrogels. Ceramics. We can use this ceramics. Composites. We can use this type of as a bioactive materials. Okay. So bioactive materials may be biopolymers, it may be hydrogels, ceramics, and composites. Applications are tissue engineering, bone scaffolds, cartilage repair, skin generation, drug delivery, then regenerative medicine. So this bioactive material can be used to develop the medical parts. In IIT Kanpur, they are developing the artificial heart also. So you use this tissue engineering concept. So this is bioactive materials are there. We have the bioactive materials. We can print that using the 3D printer, and we can generate the bones here. Okay, so this type of the bones can be generated using this 3D printer. The another very interesting topic is the food 3D printing. So for this purpose, the materials required are the purees and paste, which include chocolates, fruits, and vegetable purees, dough and batter, hydrocolloids with gelatin, agar and agar, powdered ingredients like sugar, spices, and other seasoning. Okay, customize the nutrition. So personalized diets, we can use this printer for personalized diets, elderly and patient care, creative culinary art, decorative elements, novelty items, plant-based alternative, minimizing the waste. Okay, using this food printer, we can print the cakes also. So like this type of materials we can print using food 3D printer. Okay, so in case where we are using the plastic metal as a material, so in this case you have to use the different types of the materials like this one. So this must be the input for your food 3D printer. After that, the specific materials are the textile, thermoplastics, thermoplastic polyurethane, then lactic acid, elastomers, composite fibers. This you can use for variable stretchable fabrics, variable item. Okay, for this purpose, you can print this type of for the applications. Okay, or cloths, customized clothing, innovative designs, variable technology, then medical and orthopedic. So these are the 3D printed cloths are there. Okay, like this. Okay, so this is all regarding the applications of the 4D printing, the advanced techniques, 4D printing. Then we have discussed about the bioactive materials. Okay, then the food 3D printer, textile. Okay, so these are the advanced the applications of your 3D printing. Okay, so thank you very much.